Assalamualaikum and hi. Welcome to another video for chapter 3 for the sub-chapter of 3.3 curve of polar coordinates, and this time we will talk about symmetric tests. In general, there are three types of symmetric tests. The first one, if the polar curve is symmetric at ray theta equals to 0. The second one, if it is symmetric at ray theta equals to pi over 2 or 90 degrees. And lastly is the symmetric about the pole. In order for you to show that the polar curve is symmetric at ray theta equals to 0, or if you can observe here is at the x-axis there, you need to show that f theta equals to f negative theta for the first one. And if it is a ray theta equals to pi over 2 or the y-axis there, then you need to show f theta is equivalent to f pi minus theta. And if it is symmetric about the pole, then you need to show that f theta equals to f pi plus theta. There are several trigonometric identities which is useful for you to prove this symmetric. You might use the sum difference formula, or you might also use the even odd identity. Let's move to the example. You are given any polar equation. For example, in this case is 2 cos theta. Although it is not compulsory, it's very good for us to at least know what are the shapes, what are the curves that can be generated by these polar curves. For 2 cos theta, if we sketch it, it will be this circle on the right. Okay, so we can see that it might symmetric here, and because the question is already said that shows that it is symmetric, so it's confirmed that it will be symmetric at ray theta equals to 0, which is here, ray theta equals to 0 atau x-axis. In terms of the proving, by using the trigonometric identities previously, on the previous one, which one is suitable for us to prove here? Let us start by, if we want to show it is ray theta equals to 0, symmetric at ray theta equals to 0. So you need to show f theta equals to f negative theta. Based on this polar curve r equals to 2 cos theta, f theta is equivalent to 2 cos theta. If f negative theta, it will be 2 cos negative theta. By using even odd identity, of this one, therefore f negative theta is also equivalent to 2 cos theta. And as conclusion, f theta is equivalent to f negative theta for this r equals to 2 cos theta. Therefore, it is proven that it is symmetric about the ray theta equals to 0. And let's try to show otherwise, the same polar curves, but this time we try to show that it is not symmetric. Not symmetric about the ray theta equals to pi over 2. Okay, we want to prove that it is not symmetric. We try to, another angle this time, and if it happens to show that it is a symmetric or not symmetric, we need to show that f theta equals to f pi minus theta, because this is the case for ray theta equals to pi over 2. We need to find f theta first, which is 2 cos theta, no problem. But f pi minus theta, this one will be 2 cos pi minus theta. And for the 2 cos pi minus theta, you need to you might use sum difference formula, or you can use even odd identity as well. But perhaps right now I want to try to use the sum difference formula. Therefore, 2 cos pi minus theta equals to 2 cos pi times cos theta. Because this is a minus sign, it will be plus here. Sin pi times cos theta. Whereas cos pi is equivalent to 1, sin pi equals to 0, so 1 times cos theta plus 0 times cos theta. No, cos pi is negative, negative 1 times cos theta plus 0 cos theta. Okay, and then simplify this, you will get 2 times negative cos theta plus 0. You will get negative 2 cos theta. So for this case, f theta equals to 2 cos theta, whereas f pi minus theta is equivalent to negative 2 cos theta. Definitely 2 cos theta is not equal to negative 2 cos theta. As my conclusion, f theta is not equivalent with f pi minus theta, where it is shown to be not symmetric. Ray theta equals to pi over 2. Okay, so we have proven about it is symmetric at ray theta equals to 0, and it is not symmetric at ray theta equals to pi over 2. Let's proceed by finish this question. Just now we already shown that it is symmetric. By showing that f theta equals to f negative theta. Now you need to plot the curve up until pi over 2. If you do this for this case, 2 cos theta up until pi over 2, you should get this circle. Okay? Because it is up until pi over 2 only. You can refer on how to plot this on the previous video lecture. And based on the symmetric property, okay, identify first the symmetric line. The symmetric line is here. This is a ray theta equals to 0. By using the symmetric property, you complete the circle. Okay, this is the one with the nice representation there. Okay, it's a complete circle. Okay, let's try another one. This time is about another equation of a cardioid. Okay, let's try another example. This time is about r equals to 2 plus 2 sine theta, and this time you are required to show that it's symmetric about the ray theta equals to pi over 2. When you get this, automatically know that you need to show that f theta equals to f pi minus theta. For f theta is quite direct. And what is f pi minus theta? Okay, sine pi minus theta. Again, you can use sum difference formula, or you can directly use even odd identity, but this time we'll do both. First, I need to this is sine right now, sine pi times cos theta. This one is minus, therefore this one will be minus. Okay, cos pi times sine theta. Okay, sine pi is 0 times cos theta minus cos pi is negative 1 times sine theta. Simplify this, you will get 2 plus 2, 0 plus sine theta, which at the end becomes 2 plus 2 sine theta. And it is shown that f theta equals to f pi minus theta, which at the end proven to be symmetric about the ray theta equals to pi over 2. Very easy. Okay, then you need to plot the curves, and then by using the symmetric property to sketch the whole curve. Where is 2 plus 2 sine theta? Okay, you need to plot the curves for this polar curve 2 plus 2 sine theta starting from negative pi over 2 until pi over 2. Okay, therefore you do the table and you try to plot first. Try to find the value for negative pi over 2 for this value of r. Okay, for the theta and then the r. Starting for negative pi over 2, and then can we make until the 0? And then pi over 2. Okay, try to find this one first. You should be able to get this value, and then let's try to sketch this. So it starts at 0, goes to 2, and goes to 4. Okay, this is when we map it from negative pi over 2 until pi over 2. And identify that by using the symmetric property, it says that it is symmetric at ray theta pi over 2, which is the y-axis there. Then you complete this cardioid. There. Thank you. I think that's all for this symmetric test video. Until we meet for the next one, which is the area of the polar curves. Thank you.